Hello and welcome to GM-BIST construction. Today we are going to continue from where we stopped in our last class. In our first class, we were able to carry out our to build out our roof truss point load. We were able to insert our supports. We were able to analyze and we were able to check our analysis. Today we are going to continue from there. What we do first is to carry out our section steel design to detail our drawing, our structure, that is our trust, and to export it to AutoCAD. So we begin. Now click on Steel Truss section design. If you click on it, now you come to any of the elements. Once you click on the element, you know whether the element is in compression or in tension. So let's move down. Let's just randomly pick. This one is in compression. Though the compression is high. Let's see the length. Okay. Length. The length determines the slenderness of the truss, the structure, or the element. It's one of the factors that will determine whether the truss or the element is slender or not. So you can see that most of the elements here, most of them are within this range. The lengths are within this range. Let's try to check another one. You can see that within the range because we try to space them at equal distance. You can see that within the range. So I can just pick one of them. Let me pick the one. This one is intentional. I want to work on, because those ones intention, you don't actually need to carry out anything, just to select your section, and you don't need the software will actually analyze everything for you. So pick a one which is in compression. Okay, let's check the length. Okay, I'll work on this. Then our design will be using channel section. Let's pick we'll start with a lower section and see. Okay. Now note, if a member is in compression, you must enter compressive strength PC to finish the design. See BSSO part 1 or steel designer manual table 23 and 24. Is usually a curve. You get a curve at that and then you trace the value down. So our number of section, I want two sections to be welded together. And because of the span, you can actually try one, but I want to, for my analysis, I want to use two. Okay. Steel section design. Check. Slender check. Section is not slender. Why? Because of the length here. The length is not much, so there's no way. Like in our reinforced concrete design that you discover that the longer the column, sometimes, or let me say the higher the column, sometimes if the size of the column is little, you discover that the column may be slender. So in this case, the length also determines whether the element will be slender or not. So by compressive check and statue, section is not okay. So what's our compressive resistance PC? Is a PC that you are to finish the design, you must input the value. So that if I input my compressive strength, the PC now, this one I will compare it with the resistance. So let me try to insert a value and see. So you can actually get this from the design curve. Section is still not okay. So I will check another section. Number of section 2. And try again. If it doesn't work, I will still move up. Section is not okay. And so steel design is all about trying different ways. Pick element you try, you pick until the one you save, and you try to be economical. I can actually pick this one, the first one, but you discover that it may not be economical. So actually try from the list. You keep on progressing that way. So let me choose this section. C2. Section still is not okay, but my distance is not slender. Okay, two. Section is okay. So with this I can actually match. I can match property. Okay, we have work on element 104. Let me check an element which is in tension. This one is also in compression. 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 This one is in tension. 254 okay. Just channel 254. This was the section I used. You can see that section is okay. Slenderness check. Section is not slender. So once an element is in tension, the software will automatically do the calculation for you, and you don't need here to begin to stress yourself selecting or inputting compressive strength PC. You don't need to do that here. The software will actually do the calculation for you. You only need to work on those elements that are in compression. Those ones are the most critical ones. So we close. You can do that for all of the elements, or you can just match property. So the next thing you go to is, you will now, after the calculations, the analysis have been done, the next thing you need to do is just to select detail elements, detail truss elements. You can, if you want to see your truss element force diagram, you can click anything you want to do. If you need all the details, you can actually click calculate element table length, all of that, they are here. What I just need now is my details of the truss element. So I'll just click on it. So you can see that the structure have a very nice detail. So let me reduce the scale. Make sure you run the analysis, you insert your section before you go to your details. Don't rush to this, please. Having the detail alone will not help any issue. You need to know the section you're going to use for your work, and you make sure the analysis and everything is okay, it's done successfully. Make sure the sections, the elements are okay. Those ones in compression, you check for all of them. So you have your details now. So the next thing we do is just to export it. So you can see export all drawing pages, export drawing to AutoCAD DXF. So I'll click on this. I just need the details. So I will save in my desktop truss element drawing 1. Just save it. Then I'll go to AutoCAD. I'll just click on here, open. Element. This truss element drawing 1. Click on it and open. So we have a very nice work that has been done by the software. This is so nice. So with this, you have done your analysis, you have done your you have gotten your section, everything is successful. Then you go to your details, you have your details. So I will now copy this. Bring it here and keep it here. So we are done. You can also try to get it. You try to get the truss for this one. So thank you. If you want, you can actually dimension this. In our next tutorial class, will be designing a more complex structure where we have to where we have to show more details of our roof truss. So thank you. Make sure you subscribe, you like, you comment to our YouTube channel. You can also contact us for the software if you need it. I bet you Quick Civil series, Quick Structure, also known as CIVILSOFT, is one among the best and fast software you can actually use to carry out your analysis, both your reinforced concrete design and your steel work. Thank you, and do have a nice, a lovely day ahead. Always remember that at GM-BIST, GM-BIST construction consultant will always provide the best for our clients, for our students. Thank you.